So chapter number 6, it is about a structure of atom. In a previous class, that means in 9th class, you learned about some important things just related to the atom. So before going for atom, I'll remind you some basic concepts about matter here. So what is considered to be a matter? According to chemistry, everything is considered to be a matter, but simple small conditions are there to consider anything as a matter. They are here what? Something mass. It may be very smaller. That mass compulsory with a substance. So any substance considered to be a matter if it has mass and occupies something space. So if any object or something substance having the mass and occupying the space, then it is considered to be a matter, right? So matter is made up of, right? So here matter is made up of tiny particles, right? So any substance, it is made up of what? Tiny particles, right? So here, is it possible to make them divide into further? Can we see particles first? Yes, we are able to see, but not always. For example, here now in your presence, in the room, around you, not on the surface, around you, in the air, can you see the particles? No, not possible to see the particles, right? So here, if completely you are in a dark room, just use a white colored light, maybe your phone flashlight or a monochromatic source of torchlight, white light that you can use. Just start, switch on. You are able to see some particles floating in the air, right? So here particles are visible sometimes, they are not visible sometimes. So we can decide that maybe or may not be visible directly, right? So only in the presence of light you are able to see them, because that particles are very smaller, tiny particles. So maybe or may not be visible directly, right? Then here, what is an atom first? What is an atom? So here atom is nothing but a particle, but that particle must be in a smallest division. Further division is impossible. So that particle is called as here atom. So it is the smallest particle of matter which cannot be divided into further. So no further division. No further division. So that smallest particle only called as here atom. So simply here what we are able to say, matter is made up of atoms. Matter is made up of atoms. So that's why you need to have an idea about the atom first. Because any matter, it may be drinking water or eating food substances, right? Or your articles, maybe book, pen, eraser, everything, right? Around you. Your body also made up of what? It is a matter having mass occupying the space. So to understand everything in your surroundings, including your body, you need to learn about the atom. So that is the reason to learn about this chapter, structure of atom. So what is meant by structure of atom here? So before going that, here I am asking you one more question here. Are there any other particles inside the atom? What is inside the atom? Yes, we have more particles inside the atom. Sir, you said particles only here, smallest, they are only named as atom, right? So here, particles inside the atom are called as subatomic particles. What they are called as subatomic particles. Sometimes we are unable to see the particle, that means atom, right? So further particles are there inside the atom, but you are unable to make a part of atom here, right? So that further we are observing inside the atom. Are there any existing of particles, right? So that existing particles inside the atom are called as here subatomic particles. There are nearly 200 wide variety of particles inside the atom. That atom only may be invisible, but inside the atom we have nearly more than 200 variety of particles. They are here electrons, protons, neutrons, mesons, pions, bosons, positrons, right? So many are there. Some are unnamed, right? So among them, we are giving only importance to the electron, proton, and neutron, right? Only we are giving importance to the electron, proton, and neutron. Why? Why? Here, how you defined matter? Matter is made up of atoms. What are atoms? Atoms are smallest particle of matter. So matter consisting the mass, having the mass. That mass is because of what? Atoms. So atom also having mass. So that mass constituted by major particles, electrons, protons, neutrons, right? So that atom existing due to the mass constitutes by electrons, protons, and neutrons. So that is the reason to consider only the major particles, electrons, protons, and neutrons, right? So we need to understand about these electrons, protons, and neutrons, as well as how they are arranged in the atom. So that is only here structure of atom, right? So that is only here structure of atom. Understanding the particles called subatomic particles, electrons, protons, neutrons, and how they are existing in the atom, how they are arranged inside the atom. That understanding only called here structure of atom. Have you got idea about this title? Yes. So now you have something idea about your topic, structure of atom, what we are going to learn in the structure of atom, right? So here simply it is to understand about the matter, right? So in the first lesson, matter around us, you learned about different states of matter. What they are here? Solid, liquid, gas. So here you understood about the arrangement of particles in the matter. That means atoms in the matter, right? So that atoms are arranged in the matter, right? So in different states that matter is existing, solid, liquid, gas. So that arrangement of atoms may be very tightly closer to each other within the solids, right? That gap is observed in the matter. That gap is more comparing with the solids. In liquids, that is very more between the particles gap, right? So that is in the gases. So they are separated, right? And they have something attracting property between them. That's why your solids are strong. Easily you are unable to break. So here there is existing something force between the particles. What that? How they are having that force between one to the other? Is it attracting force or repulsive force? Okay, maybe attracting force or repulsive force. How they can acquire that energy, right? How they are having that attracting and repulsive force between the particles, right? It may be because of charge present in the atom. What type of charge is present in the atom? That charge may be negative or positive, right? Is there any particle present without any charge? Yes. So these are all the things we learned in a 9th class, right? Here there are mainly 3 types of particles existing. They are named as here electron, proton, and neutron, right? So here electrons are negatively charged particles, protons are positively charged particles, and neutrons are neutral chargeless particles. They are chargeless particles. So negatively charged particles are named as electrons, positively charged particles are named as here protons, and chargeless particles are called as neutrons here. So we need to understand about these particles, how they are existing in the atom. Okay, come to the atom here. Atom is a charged body or a chargeless body? Can anybody answer me? Atom, a charged body or chargeless body? How this atom is existing? With the charge or without the charge? How do they exist? As chargeless or having the charge? They are actually chargeless. They are actually chargeless. Having the charged particles inside the atom, still they are existing without charge. Zero charge. How it is possible? Having these charged particles inside the atom. So here, to understand about the atom, scientists try to give a structure for the arrangement of these particles in the atom. The thought in different ways, how they are arranged in there. Okay, arranging is going on. Arranging is going on. But how to arrange them? Before going to arrange that particles in the atom, you need to count the number of charges present within the atom. Count is important, right? Then that count equal or different. That means number of positive charges are equal to the number of negative charges, or they are different. So they understood everything. They calculated the presence of electrons inside the atom and protons inside the atom and number of neutrons. Everything they calculated. So before going that, already you learned about these electrons discovery, proton discovery, and neutron discovery. Electron discovered by J.J. Thomson and it was named by E.J. Stoney. Here completely not by J.J. Thomson only. Before that, here they thought, several scientists, still they are working, right, to understand about that electrons. Still they are working, right? So before that, before J.J. Thomson, many are struggled to understand about that electron, right? But that particularly something information given by J.J. Thomson. Later on also it was studied by many other people, right? So that credit goes to J.J. Thomson, right? So here J.J. Thomson introduced that and J.J. Stoney named that. Then positive charge gold stain, then Chadwick neutron. So later on subatomic particles also discovered, right? Here before that, here how do these subatomic particles coexist in an electrically neutral atom? Atom is electrically neutral, no charge to the atom, right? Here how do these subatomic particles coexist in an electrically neutral atom? So they are arranged maybe in this manner. They thought. So J.J. Thomson given plum pudding model compared with watermelon, that red pulp and black colored seeds, right? Later on it is proved as failure model. After that Rutherford is given. The first atomic model was assumed by or given by John Dalton. Later on J.J. Thomson, Rutherford, some other there, right? So here many scientists are given their model, but they are failed because there are some limitations. All the characteristic properties of the atom not explained. Due to that, they are failed, right? So here some information given by each and every model, that how that electrons, protons, and neutrons are existing inside the atom, right? So protons and neutrons are in the nucleus, and electrons are around the nucleus, not inside the nucleus, around the nucleus, right? But inside the atom, they are inside the atom. So how they are existing, right? So here, are you able to arrange these subatomic particles other than this, what you learned in your 9th class? Can you try to arrange that particles, just a rough model other than this? No, it is not possible to us, right? Because many thoughts given by scientists, and they have tried in different ways, right? Actually, electrons and protons, that neutrons not visible, right? Atom only invisible. Inside the atom, how we can visible? It is with the help of a strong energy source. A strong energy source. High voltage is required to see the electron. That is nearly 10,000 volts. That is impossible to create by ourselves, right? So it is in the laboratories, they can use high energy sources, and in the presence of light, they can see, right? So that particles are visible. Then here, simply one more question. Why that, sorry, all the atoms are having the same subatomic particles? Do they exist with the same subatomic particles? Yes, definitely they are existing with the same subatomic particles. There is no other atom having other than these subatomic particles, namely electrons, protons, neutrons, bosons, mesons, pions, right, positrons, etc. Right? So that particles are present in the atom. Then what is the difference? Here they are having, but that count is different. That count of number of protons or neutrons, electrons present with the element maybe differs with the another element. That count is different, right? Then here, why is an atom of one element differ from the atom of other elements? How you can differentiate the atoms? Smallest particles. It is very difficult to separate them. They are separated easily based on the subatomic particles situated in them. So they are classified into different categories, elements, because of different number of subatomic particles situated inside the atom. So this is the classification of elements possible by subatomic particles, right? Then here, how are the elements distributed? Sorry, electrons distributed in the atom, not elements, electrons distributed in the atom. So can you distribute the electrons in the atom? Yes, we are able to distribute. How to distribute them? Within the atom, but inside the nucleus, outside the nucleus. How they are situated? What is actually nucleus? So all these questions came in their mind, right? They struggled many years. It may be centuries also, right? After that, because of efforts made by different people, scientists, so now we are enjoying that fruits of scientists. They are given much knowledge about that, to understand about arranging of particles inside the atom, that we are discussing as structure of atom here. So around the nucleus in an atom, into subshells, you are able to distribute that electrons. So distribution of electrons in the atom, around the nucleus, into the orbits, then into the subshells. That everything we will understood in this chapter, right? So before that, here you need to understand about the ripples produced in a still pond water. What is actually ripple produced in the water, right? So in your 8th class, 9th class, you learned something about sound, right? Something about sound. What is actually sound? What is actually sound? Sound meaning is what? Can anybody give me meaning for the sound? Can anybody give the meaning for the sound? No one? Right. So here sound is nothing. It is an energy form. It is a form of energy, right? So how it can propagate? Due to the vibrations created in the medium. So compulsory a medium is required. So that medium will starts vibrating. Medium not vibrate. Within the medium, what the particles are present, that particles are start to vibrate. Right? So that vibration is what? Simply disturbance in the medium. It is said to be disturbance. That disturbance only called as here wave. What is wave here? Simply it is a disturbance in the medium. That disturbance only forwarded in the medium from one place to another place. This disturbance is forwarded, that we are studying as wave and wave characteristics. What are here? Wave and wave characteristics we are studying here. What are the characteristics? They are here, namely, what is wave? What is wavelength? Called lambda. Then number of vibrations produced in a second called frequency. Particles vibrating from their mean position, or they are completely transferred from one place to another place. That we need to understand. So here particles are vibrating. They are not forwarding. Right? So what is here vibration and what is here oscillation? Do the vibrations are propagated in the medium due to the motion of the particles or vibration of the particles? Right? So only they are vibrating from their mean position. Vibrating from their mean position. So here energy is propagated due to that particles. How the energy is propagated? Without movement of particles. Movement is there, but they are not changing, not displaced. The displacement is given only in the region here and there. So that type of motion, to and fro motion here. They are called as to and fro motion, back and forth motion. Right? So that all the things you need to understand here. Right? So already you have something knowledge you gained in your previous classes. So ripples in still water. So what happens if you drop in a still, that a stone in a still pond water or in a bucket? Just put your finger and remove. What happens? Can anybody observe these things in your daily life? If you put your finger in the bucket of water, what happens? That water remains stationary without any movement. Rohit. Water remains it's stationary? No, it cannot remain. Look at here. When you drop a drop of water in the water or something stone in the middle of water, what happens? Automatically it creates a disturbance. Look at that. When the drop fall or dropped on the still water, what happening here? It is producing the disturbance where it meets the surface. Right? So that disturbance is remained at same location. No, it is forwarding in that. See, here it reaches completely towards the edges. How they are? It is like a circle. See here, not compulsory it is a circle. A disturbance may be in different forms also, right? But here we are not giving importance to that. We are giving only importance to the vibration here. So how that still water look like a plane surface, that here simply causes a disturbance due to the dropping of water in it. Right? That disturbance is what comparing with this surface, plane surface. So here that sometimes comes upward to this plane surface, and in the next attempt it will go to the downward of the surface. So upward, downward, upward, downward. Or suppose if you take a spring, if you disturb, what happens? It compresses and expands, rare fractions, right? So that we can understand here, right? So here, these type of waves are what? So we'll look at that. Here, look at that. Simply, if you take a thread, into your hand, then tie it at one of the end, and from the other end, you can disturb as you see here. You can disturb that as you see here. What happens if you disturb by tying it from one end to the other end? So here you already learned in your 9th class producing the waves, right, by disturbing the particles. So to understand about that, simply I am suggesting you to take a thread or rope. Just one end of the thread will be tied to a pole, then other end will be holded in your hand. Just move your hand like this, holding that. What happens? That will create a disturbance as you see here. As you see here, look at that. What happened? That particle is moving. Is the particle is moving or the disturbance is forwarded? Can anybody answer me here? What happens? Only the disturbance is forwarded, but not the particles. Particles are vibrating only from their mean position. When they are rest, they will be look like here. They will be look like here. So here it is the main, sorry, just a second, I'll change the color here. So this is the main position, rest position of the rope, what you are taking, right? Once that rope is disturbed by your hand, what happened? Once this is disturbed, what happened? Look at clearly. Here the particle is moving up and down here to that horizontal direction, right? So this is the rest position of your rope. Then once you disturbed, it is moving up and down like this. So here and there only. That vibrations are particularly perpendicular to the propagating direction. The disturbance is forwarded from your hand towards the pole. So this is the direction of wave propagation, but the particle is vibrating up and down, upward and downward. So this is called a transversal wave. What the wave type is? Transversal wave. So in a transversal wave, the particle is perpendicularly moving up and down, but the wave propagation, that means energy is transferred, only the disturbance is forwarded. Look at here. Just try to understand that. Here, simply you are able to see that energy is propagating. Once if you disturb that spring, what happened here? Simply that disturbance is forwarded, but not the particle. Simply edge is holded in your fingers. It is in your hand only, not moving to the other end. Only the disturbance what you are created, it is only forwarded from one end to the other end, not the particle. Try to understand that. Right? Particles only vibrating from the mean position. They are not forwarded. So this is happening in the transversal wave. So here, simply look at here. Simply look at here. I'll stop that animation for some time. Right? So here, what happening here? See here, this particle is reached to maximum displacement at this position. This is the maximum displacement given by the particle, which is situated here. So this maximum displacement, what is given by the particle is here toward this position or in this direction, that we can call it as here simply amplitude. Maximum displacement given by the particle in its vibration or in the wave. Wave is what? Disturbance. The disturbance is given by what? Energy. Energy only creates the disturbance, remember. So amplitude, then this particle will give you the maximum displacement in perpendicular direction. Okay, in the wave propagation direction, these particles which are situated at this level, right? What these are actually here, simply they are located at same phase difference. So they can create crest and trough where they can goes to minimum inside depth, inside opposite side to the wave propagation direction, right? From the mean position. This is mean position, right? From the mean position, it is moving upward and downward. So these are in same phase difference. So the distance will be equal. This distance will be equal. That distance between successive crests or successive troughs are given as here wavelength. What we can give in it as wavelength. So that phase is important. That which are at same heights and which are at same altitude or depth from the mean position. That particles you need to select and that distance you need to measure. That we can call it as here wavelength. See here, when the wave is propagating, that wavelength always remains same. No change in the wavelength. See that. Is the gap is increasing at anywhere? No, that gap is not increasing. Always it is same. If you change the energy, then it changes. Then only it changes. If you constantly providing the energy, the disturbance also forwarded in the medium with the same characteristic properties. Are you following me? Is it visible clearly? Understanding? Yes. So here energy is important in creation of disturbance in the medium. That disturbance only forwarded. So this is one of the wave. That vibrations which are perpendicular to the mean position, horizontal wave propagation direction, perpendicular to the vibration. So here simply you understood about transversal wave. There is one more type of wave here. So now look at here. How this? The same spring I used, but the disturbance created by me is differently now. I selected a flexible spring. What happening here? See, when I disturb like this, sudden jerk is given. Here, understood about the disturbance and the particles vibration. Both are in the same direction, or one is in horizontal direction and the other is vertical direction. How they are? Look at and give me your answer. What is the difference to the previous and now? Previously observed this disturbance. Previously you understood this disturbance. Now you are understanding this type of disturbance. Have you felt the difference? Right? So give me answer in the next meeting. Join immediately.